Hello and welcome to Week 13's Jing for CAS 210, Data Structures and Elementary Algorithms. Jason here, and this week we're going to take a look at the lab where we kind of dive into a bubble sort versus a frequency search. And the important takeaways I got from this week is that this bubble sort is very inefficient with our very large data set that we have here. But it's not completely useless because if we can chop this data set down, it runs a lot more efficiently. But then we have a frequency search that is different because basically the bubble sort, we're kind of doing an in-place sort where we're looking at each item, and if the first item is larger than the other item, then we're basically going to do a swap and change the location in the list until we go through the list and it's sorted, which of course the more items we have in our original list, the longer that's going to take because we're going to have more items to go through. Whereas this frequency search, we're basically looking at the most commonly occurring items, and we're sorting it based on that criteria, which also because it's not really an in-place sort, we're appending our items that are found into this temporary list, and then that's what we're returning at the end here. So as in regards to time performance, this frequency sort was fairly consistent because as you can see here, we had our sample size, the full size sample with the bubble sort took about 46 minutes, which is huge. Whereas the frequency search took about 2 seconds. So that's a huge time performance. It would be easy to just disregard the bubble sort altogether and say, why would I even use this because it took me 46 minutes? Well, we have to kind of evaluate, like I said earlier, as we cut down our sample size, this bubble sort becomes more manageable. It becomes a little more useful. Of course, it's probably not the most perfect thing in the world for sorting. There's probably better algorithms, but you can make it usable. And I think that's what's important of using these statistics and kind of weighing the pros and cons, because this frequency search as well, if I run it, yeah, it works. It gives us something that's a little more organized, but it's not sorting in perfect numerical order. It's basically saying, okay, we have our data set and this value occurs 6 times, this one occurs 6. We're basically going to sort it based on that. Whereas the bubble sort is going to, I'm just going to use one of my smaller ones, for example. Save it. Basically, this bubble sort guy is going to return us a more manageable, it's going to be a numerical order, which is really what we want when we're sorting. We want to see something that's in a nice order, as you can see here from the results. Go to the top. You can see it's in perfect numerical order, which can be very useful with data. So basically the takeaway is each of these algorithms has pros and cons. One's definitely more time efficient than the other, but it's kind of comes down to what do I need my algorithm to do, and basically this bubble sort's probably going to be more useful than the frequency search. So it would be a matter of making our data a little more bite-sized to help this bubble sort work. So that's what I have for this week's Jing. I'd like to thank you for watching. We'll see you next week.